Hello, in today's video we're going to be talking about oxidation numbers. Now we as general chemists have a certain set of rules that we follow when dealing with oxidation numbers. It would be helpful if you would open up your textbook and turn to page 155. It has a little box that has the rules for oxidation number. If you don't have your textbook or it's an online version and you want to watch the video at the same time, you can always download the notes for Monday's class. There'll be a copy of the oxidation number rules in there. So let's take a look at some of the rules that are on that table. The first rule is any element given that it's in its natural state, it will have an oxidation number of 0. So let's see what that means. So let's say we took calcium, just regular Ca, it's not in its ionic form, just pure calcium. We would give this an oxidation number equaling 0. The reason why that's the case is calcium is found as calcium on planet Earth. It's just a Ca. We can also look at things like our diatomic elements. O2, that is its natural state. Although it's a molecule, a compound here, its natural state is going to be in the diatomic form. So we would also give an O2 an oxidation number of 0. So any element that's on the periodic table that's in its natural state, it will get an oxidation number equaling 0. Okay, so that's the first rule. Another rule is that monatomic ions, the oxidation number of monatomic ions, will take the oxidation number equal to the charge of that ion. So what in the world does that mean? I told you before, we've come across the word monatomic before. All that means is a single element, a single type of element. So if I have CaS, calcium sulfide, we know that this is an ionic bond. There's a nonmetal and there's a metal. And so this is an ionic bond, which means the calcium actually has a 2+. So I'm going to break this down. The calcium has a 2+ charge. We know that because it's in group 2 of the periodic table. And the sulfur has a 2- charge. We know that because it's in group 6 of the periodic table, group 6A of the periodic table. So that rule about monatomic ions says that whatever their ion charge is, that is equal to their oxidation number. So calcium's oxidation number here will be equal to a 2+. Sulfur's oxidation number will be equal to a 2-. That's all that states. So anytime we have an ionic bond, we just have to figure out what the charges are on those ions, and then we can figure out what their oxidation number is. So this was an easy example just because those are main group metal to main group nonmetal. So let's look at a transition metal to nonmetal. So this is where your naming rules come into play. If you can correctly name these compounds, you will correctly identify what charge is on these compounds. So if I take VO2, so V stands for vanadium, O stands for oxygen. So this is an ionic compound. Vanadium's a transition metal, oxygen's a non-metal. So in this case, I don't know what the charge is on that vanadium. I have to back calculate it. We have a rule on the table that states that oxygen will always be a -2, except when it's in a peroxide. But for this class, we're never going to deal with a peroxide. We are only going to deal with oxygen having an oxidation number of -2 if it's in a compound. Not O2 by itself because that's its natural state. So we know already oxygen's oxidation number is going to equal a 2-. We also know that its charge is a 2-. So at the very beginning of class, when we were talking about naming, very beginning of the semester, I told you how to figure out what the charge is on that vanadium. I gave you an equation. I'm going to give you that equation here as well, and then we can figure out what the charge is on that vanadium. We set 0 equal to the number of metals times the charge on the metal plus the number of nonmetals times the charge on the nonmetal. This is the equation that I gave you at the very beginning of the semester. We know that there's one metal. We don't know the charge of the metal. We know that there are 2 nonmetals, and we know that each one has a -2 charge. We can solve this equation so that the charge on the metal is equal to a +4. Okay? So this is just simple algebra. You should all be able to do this at this point. So we know that this is really vanadium 4 oxide is the name of that compound. So vanadium has a 4 plus, which means its oxidation number is equal to a 4 plus. When we talk about oxidation numbers, it's not the total amount of negative charge here, since there were 2 oxygens, it's the oxidation number on each of those elements. So that's what we have here. We can also do one more example that has 3 different elements, and then we'll be done. So I'll make this one quick. HNO3. This is a little more difficult, but we have that same equation. We just have 3 numbers here. We know we have a rule for hydrogen. Everything in group 1 is a +1. So I'll start writing my oxidation numbers above each of the elements. Oxygen is always going to be a 2 minus. So now we can write the equation. We have to figure out what the oxidation number is on nitrogen. So 0 is equal to 1 times the charge on hydrogen, +1, plus 1 times the charge on nitrogen, plus 3 times the charge on oxygen. So this turns out to be the charge on nitrogen is equal to a +5. And that's all there is to it. So we know that hydrogen has a +1, nitrogen has a +5, and oxygen has a 2 minus oxidation number. Remember, this is all a covalently bonded system. It's all, the NO3 is a covalently bonded system. The H is not. The H is ionically bonded here. So we have ways of figuring out what all of the oxidation numbers are on each of the elements. Generally, when we have a set of 3 elements, we won't know the central atom, the oxidation number on that central atom. So with that, I want to say I will see you all in class tomorrow, and we will do a lot of these types of problems in class tomorrow.